Hello, this is Mr. Bush here, and we're going to go over everything we've basically learned for the last couple days. So first off, we're going to go with specific heat. Long story short, it basically is the amount of energy required to heat up a certain amount, like usually typically 1 gram of an object. Everything heats up at a different rate. Example, water heats up at a different rate than metal, or let's say copper heats up faster than glass. And the amount of energy required to heat an object, that's specific heat. Alright, so with specific heat, if it has a high specific heat, it's basically going to heat up slowly. If it has a low specific heat, it's going to heat up fast because it requires very little energy to make it hot. So we're going to go ahead and look at a few examples real quick. Alright, a good example of this is basically sand and water. As y'all remember from the experiment, basically sand will heat up fast because it has a lower specific heat, and water will heat up very slowly because it has a high specific heat. Alright, and this basically is what creates local winds. Winds are created when the sun unevenly heats the Earth's surface. Alright, so basically I just went ahead and wrote that down, so if you wanted to pause the video, take a few notes, you could. This kind of makes sense. Everything does not heat up at the same rate, therefore sand, water, dirt, grass, all these things are going to heat up at a different rate. That's going to cause differences in pressure, and that's what's going to create winds. Alright, now whenever the Earth heats up unevenly, it basically creates a difference in pressure. And high pressure always pushes into low pressure. So you're always going to have basically this effect of your high pressure having a greater force than your low pressure, and it causes basically the high pressure to push into that area. Now, for high pressure, it's always going to be very stable. The weather's going to stay the same. Whereas in low pressure, you're going to have a change. It's going to be unstable, typically stormy. So we're going to go ahead and get that down real quick. Alright, so you can go ahead and pause this and get this copied down. But basically, high pressure systems are often stable. The weather stays the same because, well, no other air can push into that area. So it's going to basically remain the same. Typically sunny and stable weather. Low pressure is often going to be unstable, stormy. Basically, because it does not have enough force to push out a high pressure system, new air is going to move into the area and change the weather. Now, the next thing we're going to look at is air masses, and there's 4 major air masses that we're going to look at. Alright, so they classify air masses based off of 2 different things: temperature and humidity, or how much moisture is in the air. Now, anything that's cold is going to have the name polar in it. Anything that is tropical is basically going to be hot air, so anything that's hot is going to be called tropical. And that kind of makes sense. Anytime you think of polar, it's a cold region. Tropical is a warm region. Alright, so let's go ahead and look at the moisture. Alright, so maritime winds are basically, or maritime air mass is basically going to be humid or wet. And because maritime comes from the word marine, which means ocean or water. Now, continental is made of land, which means continents are going to typically be dry. Anytime an air mass starts over land, it's going to be a very dry air mass. So, in our area, if we get basically a air mass that comes from the Gulf Coast, it's going to typically be a maritime. That's where we get most of our rain from. And if the wind comes from New Mexico or Mexico area off that continent, that's going to be it's going to be called a continental air mass, and it's very dry. Or if we get wind from the north, which is going to be from like Canada, that would be also a continental wind or a continental air mass, and it would be very dry. Now, anytime you're naming an air mass, you basically combine these. If it's a cold, dry wind, you would call it a continental polar air mass. Or if it was let's say a cold, wet wind, you'd call it a maritime polar air mass. All right, we're going to go ahead and look at one more thing real quick. All right, now these are the major air masses over America. If you look up here, anything that basically, anything that's going to come from the ocean, that's going to typically be a maritime air mass. Now, anything from a continent, that's going to be basically a very dry air mass. So anything that starts on a continent is going to be continental, because it's going to be dry. Anything over the ocean is going to be maritime, because it's going to have a lot of moisture. Now the temperature, almost everything in the south for America is going to be tropical, because it's going to be very warm air masses. Anything that starts from the north is going to be polar. And you just basically combine the two words to describe the moisture and the temperature of an air mass. Hopefully this helps you on the homework. If y'all have any questions, feel free to send me an email or bring them in tomorrow. I'll be happy to help you with it. And y'all have a great day.